So last week we learned the radical and roots, and especially including the how to define the roots, and also which one related roots. Actually, we talked about a lot, like the square root, right? But only two was not defined, and the cubic root. We didn't go that too far. And then also try to talk about say something like is how to if the in this cubic square root and cubic root, we overall write it like this, right? And if this root n is an even number, the inside the radicand here, should be greater or equal than 0, right? When they are odd number, like a cubic root, this n can be any number from the negative infinity to positive infinity. But if they are even numbers, the underneath here should be greater or equal than 0, right? So just like this one, when the square root x square root here, so you should add here, if they didn't mention you x is positive or negative, x should be given the absolute, make sure they are greater or equal than 0, right? Yeah, so here square root here. So like similarly, like some example like here, we extended the radicand, actually have different kinds of format. If there is one term, the square root, we can use this. And if there are multi terms, if polynomial terms, right? So you have to change like this, right? And if they are like this one, like polynomial terms, the multi terms, we need to do proper transform. Like inside this part, they can be changed into like this, right? So actually, this one actually is the factor. So the result, it would be like this, right? So actually, basically introducing how to simplify, how to talk about the root and radicand. And after that, we move to simplify, actually, just like most, how to, when they have different kinds of format, how to simplify it. When they are numbers, they are easy to do for you guys. This one you have to be learned in the pre-algebra part, right? You have to know under how to go in, like quickly know, like this one, you should be know, this is 100 times 2, right? So square root, this 100 can take it out, can simplify it. So something like these parts, and you can, this one can be right into like this, right? And this part is 2y squared, right? And 2y can take it out, can simplify it. Okay? When there is in this kinds of fraction version, you know that the square root AB, this one can be write down AB. And if they are A over B, and they can write it into A over B, right? And, but of course, make sure A and B is greater and equal than 0 before you do this kind. Those things here, right? Right. So like this fraction, so you can do, see this one is equals, right? So can do it separately. So it became p square root 5. The bottom is became 3, like simplification, right? All right, so we can move on to do the addition and subtracting radicals. Actually, that part is really close to, try to identify the radical is the called similarity, called like terms, called like radicals. This is like similar to earlier what we learned, like terms, the radicals. So if they are square root plus 2 square root, we also can be changed to 3 square root, right? Like this. This is like terms. But if you say square root 2 and square root 3, you can see this 2 is different. They cannot combine. They cannot combine. So first we need to simplify first, right? So like square root x plus 2 square root x. Similarity like this part. So this is like radicand, right? Like radical. So they can combine, become 3 square root x. Similar to the minus. So when the minus became negative, right? Square root x minus 2. So the only coefficient part do the calculation. The radicand part was not do the calculation. Keep it the same. And if they are more complicated case, like similar like this case, they would you have to simplify first. Try to check if they have like radical or not. And after adding and subtracting, we goes to multiply, right? Multiply. So actually multiply actually is backward of this part. Right now we say square root A and B, you can go like this, right? So we can backward. If the two radicand time together, we can combine it into like this. Right? So it's backward. And the divide, and also we go to the divide part. I'm sorry, need a little bit more complicated. So if there only one term radicand time, another term radicand, you like this backward. When there are two term time, one of them, we need to use the distributing methods, right? Right? So we distribute inside. When there are two term time, two terms. When there are two term time, two terms. Right? So this one we use the rectangular area methods or use the FOIL methods, like first term time, first term, second term, and oil inside part, right? And the final is this one, 1 times 1. The same similar methods, right? So when they do the multiply, only one term to one term, we can use these methods. If there are two term to one term, we need the distributing methods. When there are two term by two times two terms, we use the FOIL methods. Actually, the method is exactly the same as what we're learning for like the polynomial multiplication, right? Okay, so let's move to the divide. When they do the divide part, if only one term divide another one term, so this one can combine, just like backward, right? When they two term divide one term, this one also do the same. Or you can make it stabilize, rationalize the bottom. Make it rationalize the bottom, right? And both do like this, right? So the bottom part became rationalized. There's no radical in the denominator. And the top part use your distributing methods. What about two terms? When there are two terms, so how to do that? So we use the rationalize method. Rationalize. How we do the rationalized? We use the conjugate, right? Conjugate method to get rid of the radicals. Right? This is conjugate. So the denominator part became what? B minus 1 square. So this part make it the square radical was go, and the top part use the FOIL methods, right? Yep. So you can got it, make it rationalized. Actually, we pay pretty much attention to these kinds of things. Actually, give one quick example. Like this one, you have to use the 4 minus square root conjugate. This is the sum of two terms. This is the difference of two terms, right? So top and bottom time conjugate, this kinds of conjugate. So you got 4 square minus square root 3 square, right? And top part became 8 minus 2 square root 3 here, right? The bottom part became 16 minus 3. So you got 13. The top part is 8 minus 2 square root 3. Right? So similarly, like this kinds of progress. So if they are these kinds of decimal that can have the square root x. So what we need to do is find their conjugate. Find their conjugate is 1 minus it, right? Top and bottom do the same, times their conjugate. So you can get 1 minus x, right? Square root x squared. So it became x. The top part became 3 minus 3 square root x. So there's no radical in the decimal area. I mean, in the decimal area, in the denominator area, right? So you rationalize them. All right, so let's go to the homework part to review the homework part. Take your homework out. Let's review the homework. So time is very quick. This is the week of 30. So we have this week, next week, and the week after next week. The week after next week is last week. So we will have the final exam. So we only have 2 weeks left for this time. I try to teach the last week because last week have the graduation ceremony. I try to understand how they do it, how they arrangement, and make sure we can do the exam at later week or a little bit late time, or we find another time to do the final exam. All right, because we have a lot of need to teach. So let's see this part first. Next week review homework. Take your guys' homework out. All right. If you have any questions, please let me know. All right, sounds good, everyone. Take your homework out. Let's review together. Please be focused. I talk maybe a little bit quick because homework this week, how much we here? Let me see. Only 1 page, but pretty much. All right. So let's do them together here. Take your homework out, everyone. So like this part, actually, for if there was only pure numbers, I think we just put some time to review the pre-algebra, what you learn. Hopefully you learn this one in the pre-algebra. So I can do very quick. I can just put it here is actually refresh our memory and what we learn when they are face number radical, how we do handle number radical, all right? So this is also review the homework part and also review what we learned before. And then we extend to the have any variable kinds of situation. All right, see number one here, square root 81. So you got a 9, right? Here, -7, for the square root of 49, -7, right? Cubic root of 27. We know the 27 is 3 cubic, right? So you got a 3. And here, you guys know this one, right? If your answer was different from mine, please let me know, all right? So here is 308. And here is 6/9, right? And we need to further simplify. So became 2/3. All right. Number 7, you know, here is, right? So fourth power root. So you can get a 2/3. And here is -3/4, right? Here is cubic root. Okay, so see next one, number 9, which radicals is not a real number. Not a real number means like if they are inside here is even number, is the even root, and inside is not greater or equal than 0. The inside this part was not greater or equal than 0. They will be not real number. They will become complex number. All right, so this means that when there was defined. So we know, let's see this one, a here is equal to, so they are real number, right? So here, this part is -2, so still real number. What about this part? So cubic square root inside is -4. Actually, this one is not real number, right? Not real number. So actually, this one equal 2i plus positive or negative 2i. So I will be complex number, imaginary number. That's not real number. So C is the answer. And D is cubic root, so it doesn't matter, right? So G is still real number. Okay, same to number 10. So here is square root, right? For this A. So this one is not real number. Not a real number. So here actually is square root 5i. Okay. I is imaginary number. So this one is real number. And this one not real number, right? Yeah, even. This is even root and -5. So because here should be greater equal than 5. So this one also not real. And here is the odd number. So here is real number, right? So answers is this 2 is not a real number. Anyone correct? Anyone have questions? No. Okay, so let's move on. Number 11. So only inside here is only one term, and they consider variable represent is positive, is greater or equal to number, right? X is positive. All right, so let's see what's the answer of here. Right. Number 11. So here it became 6, right? 12 divided 2 here. So here equals 3x power 3. What about this one? The top is 4. Y 5, right? Here 5, this divide 2. Let's see the 12. Here is x power 4, right? And 14, here is 5x squared. And what about this one? Y power 6 over 7. That's pretty easy, right? Only one term case. That's much easier for everyone. All right, let's see next 8.2 here, 7. So see 17. 17, still consider simplify each expression using the product rule. Just like I say. Right? Assume the variable present non-negative. So it's greater or equal than 0. Right? Okay, so see number 17 here. So here is 20. What are you guys? 6 over times 9, right? 6 times 9 equals 3 square root 6, right? 9 can take it out, it became 3. What about this one? 4 times 22, right? So you can 2 square root 22. What about this part? 25x squared times 6x. All right. So here it became 5x, right? 5x square root 6x. What about this part? 4 times 23, right? So y power 4 and times y. So we can just break like this. So after square root, so you can see the top part, the left part. I mean this kind of first factor became 2y squared and 23y square root, right? All right. See the number 21. Number 21, you can see this cubic root. So we needed 27 times 2. All right. Cubic root. So 27 cubic root became 3 times 2 cubic root. What about this one? This one is, we can got 8 times 11 cubic root. We know 8 cubic root is 2, right? So became 2 cubic root 11. What about this part? This part here is 4th. We can got a 16, right? Times 3 and 4th root. So 16 4th root became 2, right? So we can take 2 out, right? Okay. What about this one? This one is 81 times 2, 4th root. So 81 is 3 power 4, right? 3 power 4. So you got 3 and the 4th root of 2. So that's much easier, right? Anyone have challenge to this part? Anyone? Did you guys have any question to this part? Too quiet, man. Make some noise to us. All right. Make sure I understand you was there. All right. That's all. Let's move on. So if you don't have questions, I will move on a little bit quicker. All right. All right. See the 25. 25. You can see this inside right now here is a fraction. Inside radical is a fraction, right? So we actually means we want to simplify, actually need to simplify two parts and also try to make the bottom, if they are considered radicals, we need to make it rationalized. All right, so you can see this part here is the 9 over 25, right? We can times 2 and then square root. So you can see this part, it became 3 over 5 square root 2. So way much easier, right? So let's do here. It's 25 over 64 times 3 root. So you can, this part is 5 square, this 6, 8, 5 over 8 square root 3, right? But this part here, it became 9y squared times 6. Here it became 4x power 4 square root. So you can got 3y, right? Here it's 2x squared and root. Because of this part, you can become this part square, right? See number 28. 28, here is 4x power 4, right? Times 5x. And the bottom, 3x squared. I'm sorry, 9x squared and square root. Actually, you can simplify first. Here became 3, right? Inside it became, so here became power, right? So you can don't need this one. So you can got a result is 2x, here is 3 square root 5x. Way much easier, right? Okay, so here, what about this one? You can see here is 4, so 9. 9 cannot keep fourth root, so you can keep it as it is. And here became 2. You know, 2 power 4 got 16, right? So you can take it out as 2. Similarly, same here. So here is 8. 8 is 2 power 3, right? And 27 is 3 power 3. 3 cubic. So you can got it here. Times 5 and root, cubic root. So you got it. So you got it here is 2, right? Correct? Check your answers as well, right? So you got this part and this part. So don't forget this part. So actually here is cubic root. So you needed to put some numbers, powers of 3 out of here. Right? See some number 31. 8. 8 actually is 2 right here, right? 8, 2 power 3, right? So you can take it here out directly. Right? One step. So here the same. The same. One step, get it out. Okay. Let's go on adding and subtract. Combine like radicals. So we needed to identify like radicals. How do I identify them? First, the root here should be the same. The root here the same. And inside here is exactly the same. First and second, there are 2 parts. They can identify they are radical, like radical or not. Right? Okay, see number 33 here. Number 3 here. Cubic root 2, cubic root 3, they are not like term. Cubic root 3, so these 2 is the like radicals. All right, so it became what? The negative, right? The radical part was not changing. The coefficient part, 3 minus 4, so you got a -1. So with a negative here. And this part was no others, so we just copy as it is. All right. Second, 34. Let me change the color, make sure I'm not confusing. 34. So here, square root 2 negative 8 square root 2, so negative 3 square root 2, right? And this part was not changing, we just keep copy as it is, right? Right? Okay. Yes, two more here, 35. 35. Let's see 35. 35. 35 here, we can see they have these two is the like radicals, right? So you can get a 6 square root 6. This is cubic root. This is 2 and negative 4. So you got a negative 2 cubic root 6, right? 36. 36, you can see this is 2 is the like radical. So you can get negative, 3 minus 2, so it became positive, right? Square root 5. And this 2 is the like radicals. So you got a negative, positive 2. 1 plus 3 is like a positive 2 cubic root 5, right? So much easy. This is very, very easy. Okay, let's go to the 37. 37, we see the numbers inside is a complex composite kinds of term. They can be further simplified. So we need to simplify first before we do the combinations, all right? So like I say, 28x, actually you can take it 2 out. The left is 7x, right? Right. The same to this one. This is 9 times 7x. So you can 9 times 7x, take a 3 out. 9 square root 9, so it became 3, right? So the rest is also 7x. And last one is cubic root 56. You say 8 times 8. So you can take 8 out. You can take this 8 out. 8 cubic root is became 2, right? But there are no x behind. So this is not like radical front, but these two is the like radicals. So you can combine of them, right? So it became 5, 7x, and this term is separate. It's not like terms to the front one, so cannot combine. Let's see 38. 38 is 75y. So we can change it to what? You can see this y actually is outside, right? This is outside. So we need to do like this. 75 is 25 times 3, right? So 25 times 3. 25 square root equal what? 5 square root 3y, right? 48. 48 is 16 times 3, right? 16 square root 16 is 4 square root 3y. And last one here is 16 fourth root, so became 2, right? So right now we can do this combine like radicals. So here you can see this part is the like, so you can go to 9 square root 3y minus 2. Right, that's much easier. All right, 39. Let's do the simplify first. So here it became 3, right? A minus is 6. So we can do this one easily. So 1/3 minus 1/6. So you still got a 1/6. Right. All right. See number 40. 40. Simplify first. The denominator became 5, right? The numerator square root 11 and plus 11/4. So we can combine this one. We'll take this out. So 1/5 plus 1/4. So you got 24 plus 5. So got a 9, right? You guys can do this one. This one will do a lot, right? See the 41. 41. So you can see this part. This part has 5 cubic became 125, right? So it became 10, 2 times 5. And here's 5 times, this part is 2, right? 2 cubic became 8. So 2 power 3 here is cubic root, so became 2. So you got 0, right? It's 10 minus 10. 42 here. So what about this part? Here is 8 times 2, because 8 times 2 and cubic root, right? So actually 8 take it out, became 2. 2 times 3 became 6, right? 6 minus 2, so you got a 4. You got a 4 here, cubic root 2, right? So anyone have your questions about your homework? Any questions? Any questions, guys? No, no questions? Okay. So let's move on to second right part. Right part. Our homework is critical, you know. Just make sure you guys can actually practice this one and make you familiar with these kinds of process, especially in the future when we met these kinds of problem, right? Okay, let's see 43. 43 here. So let's one term. So product and simplified, all right? Product and simplified. So let's 2 steps. You need a product and simplify as well. So here, like one radical time another radical. So coefficient part time together, right? Inside this one can time together became 50, right? 5 times 10, so it became 50, right? So right now we simplified. Actually, this part is 25 times 2. 25 square root became 5. So you got a 30. 6 times 5 got 30, right? So square root 2. All right. Anyone have question to this one? Sometimes I know people didn't do this before, will be a lot of questions. Make sure you guys really understanding here, okay? If you have any questions, please bring it up. Okay. Sounds good, everyone?
Yeah.
Okay. All right. So move on. Let's move on. So this part here, we can just like say, so it's first 2 times 5 became 10, right? Here inside the cubic root. So 4 times 6 is 24, right? 24 is 8 times 3, right? So 8 times 3, 8 cubic root became 2. So it became 20 cubic root 3. So don't forget here. Don't forget the cubic root. Don't forget this part. 45. This part actually you need to distribute inside, right? Distribute inside. So you became 2 cubic root 18. Here became 3 cubic, square root 36, right? 3 times 12. So you can got here. This one is easy, right? So you can 3 square root 2. So you got 6 square root 2 minus 3 times 6, 18. We'll stop here, right? We cannot go further combine or simplify. 46. Let's distribute inside first. So he became 8 square root 50. What about second one? Minus 20 square root 25, right? So you can get, here is 25 times 2. 25 square root is 5. So you got a 40 square root 2. What about bottom? Second part. 20 times 5. So minus 100. All right. So we go to 2 term times 2 term. How we do that? We use the FOIL methods, right? Or just like rectangular area methods. First, square root 18. Second, minus 5 square root 3. And the third, plus 2 square root 6 and minus 10. All right, we make it further simplified. Here, this one can be changed into what? 3 square root 2, right? So the rest copy. So they cannot be combined further, right? They have no like radical. So just keep as it is. Okay, so see the 48, the same FOIL methods. First, so you get 8 square root 25. Second, minus 6 square root 5 and plus 4 square root 5 minus 3, right? So here is 40, right? 40 minus 3 is equal to 37. And this one can combine like terms, minus 2 square root 5. Right? So you got these two. All right, so move on 49. 49 a little bit. So it becomes something square. Square means this one we write here, right? Oh, you know what we earlier, a plus b square. So equals a square plus b square plus 2ab, right? Use these methods. So here is first term square minus 2ab plus 2 second term square, right? So we can do it simplify. So first became x minus 4x square root x plus 4. So you can find interesting result, right? We cannot be further combined. Let's see the number 50. First term square so became y, second term square 16, and the middle term is 8y, right? 2 times 4 times square root y. You can see this one step, we can get results if you remember the kinds of formula. Anyone have question to this part? Nope. Okay, so let's move on. Okay. Now let's go 50. 51. 51. So here it's easy, right? So we can combine here first. Inside. So it became 9. 9 square root get 3. What about this one? 20 minus 5 equal 4, right? So you get 2. What about this part? Square root 20, right? So you got a 2 square root 5. What about this one? 32 square root. So you got a 4 square root 2. Everyone should be doing this very quickly, all right? All right, so what about this one? You got a 15x cubic square root. So you can take x out. 15x, right? X times 15x. What about this part? Here equals 118x power 4. Y is all gone, right? So square root. So you became 9x power 4. So it became 3x square root 2. Right? Much easy. All right, let's go to the last section of the homework. Last section actually say rationalize. Rationalize. I know rationalize when I make the denominator have no radical there, right? Okay, so this one. Actually, both top and bottom time square root 11. So you make it easy, right? Both top and bottom time same kinds. So this one became 13 bottom. Here is 39. Right? Way much easy. Both top bottom times 6. So the bottom times 6 here is 30, right? Both top and bottom times square root 10. So bottom is became 10, top part became 70. Right? And both top and bottom times square root 5x. So denominator is 5x, top is square root 5x, right? And the same here, top bottom square root 30y, 3y square root. So your bottom is 3y, 5, 3y square root, right? So looks easy, right? So how you, if there only one term, definitely easy. Right? Only one term definitely is much easier. So here bottom became x, top became 3x. And here with just one step, we can got it. And I don't write it all the time. I just one step can get out. So up to now, only one turn to one turn. Divide one turn, rationalize is way much easy, right? You just time the same. So if there are two terms, what do we need to use? We need to conjugate, right? Conjugate, all right, what the conjugate means. So this is plus, so we do the plus, right? We do the plus. So this is a minus b, a plus b. So it became 5 minus 2 square. So it became 1, right? The bottom became 1. 5 square, 5 square root square became 5 minus 2 square. So it became 1. The top part became 3 square root 5 plus 6. So you don't need this part, right? You just equal this part directly. All right. So let's see the second one, 66. Time what? What a conjugate there would be? I need to ask one person to get my answers. Vivian, can you give, what's the conjugate of number 66? Vivian, are you there? What's the conjugate of the 66? Vivian, are you there? Tommy, what's the conjugate of this 66? Thomas.
Oh, all right. So,
What should be with this?
right. Right. I think for this form, I've done it wrong. Yeah.
What's that? What's the conjugate would be, should be? You don't know?
No, I think I might have done it wrong.
Amy, what's the conjugate for here?
Radical 10 minus 3.
Say it again.
Radical 10
Radical 10
minus 3.
plus 3. Yep, exactly.
Yeah, that's plus.
So this one equal what? Square root 10 square is 10, right? Minus 9. So actually here got a 1, right? So the top part, we don't need to change it. Right? Just need to copy it. Okay, so, all right. Max, what's the conjugate for this part? Max, are you there? Max? Max was not here. Max, you show up here, right? While in the screen. Okay, I know someone was not listening. Joy, what's the conjugate for this one, Joy?
Radical 3 plus 1.
Yeah, that's easy, huh? Okay. Joy, you didn't go to the math competition last night? Okay, so what's the answer of this here? So here 3 minus 1, so got a 2, right? So top part, you guys can distribute it in type by yourself, all right? All right, and ask next. Gloria, what's the conjugate for this one? For the 68? Gloria, are you there?
Can you please repeat that?
68. What's 68. The conjugate? You'll be here. What top bottom time, what can make it rationalize?
I don't know.
You don't know? Okay, so here, so let me ask another one. So did you ever do you finish your homework?
I did, but I don't know how to explain it.
Okay, okay, so here should be what? Song Tang, can you give the answer for this one? Help to.
Radical 5 minus 2.
Yeah, so you got it here is 5 minus 4, right? So actually the binary is 1 here. The top bottom is the time same kinds of, right? Same thing, right? When you factor out, it will be all gone, right? So the top part you can say square root 15 minus 2 square root 3 minus 2 square root 5 and plus 4, right? All right, much easy, right?
That's
So
the answer I got.
Yeah. Okay, go 69. So what's the radical of this one? I need to ask someone. Anna, what's this one?
Radical x minus 5.
Yes, exactly. Easy thing, right? So this is a plus b. This is a minus b. So the bottom part became x minus 25, right? Much easy, right? So the top part, you just keep it as it is. Minus 5. All right, let me see. Ask one more person. Angie, what's the answer? What's this one? What's the radical of this one? I mean, what's the conjugate of this one? Angie? Angie was not there. A lot of people was not listening. I know behind this camera, and sometimes I cannot know what you are doing, but please be listen carefully, all right? Angie, I know you unmuted yourself.
Negative 8 radical x.
Plus 1, right? Radical x, square root of x plus 1. Okay. So you can go to x minus 1, right? The bottom became x minus 1. The top we just keep us as like this. So make it rationalized, right? It's easy, right? It's easy one. Okay. So let me move back a little bit. Can you guys print screen, make this one, make sure you, before I move on. All right, I also save one first. All right, let's move on 69. Just a little bit more left. We're almost done. All right, 69. 69. So both top bottom, what's the radical conjugate here? Conjugate is a plus b. So we need a minus b, right? Okay. So the top bottom actually is like this. So you can got x minus 25, right? X. And you got here is 10 square root x minus 5, right? Let's see the 70. 70, the same. Here we time x plus 1. That's very critical. Sometimes you not even imagine how you time something can make its radical disappear, right? Plus 1, all right? So the 70 to 70, 71 to 74, that's easy for everyone. Only is cubic root. Cubic root will make it the radical, I mean, this desiccant became some numbers, cubic, right? So we just need to times 3 inside, right? So you can go here is 27 cubic root became 3. Here became 21 cubic root, right? Same here. In the decimal, in the desiccant and I'm sorry, desiccant and numerator, denominator and numerator both times 2. So the bottom became 8. 8 became, what kinds of cubic root of 8? It's 2, right? So here is 6 cubic root, only the numerator part. So when there was 2, we times 4 became 8, right? So the numerator, the denominator became 2, right? Because 8 cubic root became 8. Here it became 12 cubic root. Same here, times 2, times 2. So here got a 2, right? 8, and here's 10 cubic root. All right, so homework part, actually, I put an additional P here. That's today's topic. Today's topic. So, whoa, what are we doing? We're learning radical, we make it simplification, we make their denominator rationalized, we know the addition, multiply, subtract, and also multiply and divide. What objective? We try to solve the problem of these kinds of equations that contains radicals. When they contain radicals, how we do that, right? Okay, so keep this in mind, keep all these kinds in mind. We make this step, we try to find solution of these kinds of variables, actually. Okay, so homework part, that's done. So we take a 3 minutes break and come back, move on these kinds of radical equations. Sounds good? All right, 3 minutes break.